In today's geometry lesson, we're going to be doing section 5.3, which is the surface area of circular solids. All of the formulas that we're going to be using come directly from this formula sheet right here. So we've got circular solids, which includes cylinders, cones, spheres, and then even hemispheres. So we're going to be analyzing all of these and using these formulas as we go through today's lesson. So we've got our Amazon notes. This first object, all right, this three-dimensional figure, this first one, this is a cylinder. So for a cylinder, we have to know two things. We have to know the height, and the height can, in this picture right here, is seen on the inside, but the height can also be labeled as on the outside. So the height is any distance from the top to the bottom, and it's in between the two bases. Now each side of the cylinder has a circular base. So there are two circular bases in this figure right here. The next circular solid that we're going to be looking at is a cone. So we have the radius that we need, and then the other thing that we need is the slant height. And the slant height is denoted with an L or a, sometimes you see a cursive L also. So that's the slant height. So on your formula sheet, you see an L, and that represents the slant height. So the height is on the inside, but we need the slant height and the radius. So in this one, we need the radius and the height. And this one, we need the slant height for the outside of the cone, and then the radius. And then finally, we have their last figure, which is a sphere. So it's not a circle because it's a three-dimensional shape, so we have a sphere. A sphere uses the radius, so we need that radius in order to figure out the surface area of a sphere. All right, so let's talk about the name of the shape and the number of bases. So for a cylinder, all cylinders have a top and a bottom. Think of like a soup can. All right, there are two bases. And then to find the lateral area of a cylinder, you're going to do 2 pi radius height. And that is directly from your formula sheet. And then your surface area is going to be 2 pi RH plus the area of two circles. So that's why we see that 2, and then next to it we have pi r squared. So the area of a circle, just one circle, is pi r squared, but since it's got two bases, that's why we have that number 2 right there. For a cone, again, this is straight from your formula sheet. A cone only has one base, so to find the lateral area of a cone, we have pi r, and then we have an L, right? So it's a cursive L. And then our surface area, so the full surface area is pi r slant height plus just 1 pi r squared for one circular base, right? One circular base. And then finally, we have a sphere. There are no bases in a sphere. There is no lateral area, because remember, the lateral area is just the area of the faces, so there are no lateral area for a sphere. And the total surface area is 4 pi r squared. So again, that 2 pi r comes from two bases of a circle. So that's what we talked about previously, all right? And then it says, why do we add pi r squared to the lateral area of a cone? This section, this pi r squared, is the area of the base. All right, so for all of these, we're going to find the surface area and lateral area where appropriate. We're going to be going straight to our formula sheet and just applying all of those formulas directly. So the first shape, this is a cylinder. So to find the surface area or the lateral area of a cylinder, we have 2 pi, and then we have the radius, which is r. It's my radius. And then we have my height, which is 5. So we have 2 pi times 2 times 5. So you're typing directly into your calculator 2 times 2 times 5. You're going to get 20 pi. For my total surface area, we have that 20 pi plus the area of the two bases, or you can just use the formula. So we have 2 pi, we have times 2 times 5, and then we have plus 2 pi, and then this is r squared. So I'm going to take the number 2, and then we square it. So we already have that 20 pi previously, and then we have plus 2 pi 2 squared, which gives you 8 pi. Now, you're going to combine 20 plus 8 to get you your total of 28 pi, and then both of these are centimeters squared. For number 2, the shape is a cylinder, so there is no lateral area. So all you're doing is finding total surface area. In this figure, my radius is 10, so we're going to go straight to our formula for my total surface area. So we have 4 pi, and we have some numbers squared. The number that we're going to square is 10. So all you're doing is typing in 4 times 10 squared into your calculator. And 4 times 10 squared ends up being 400. And then all you have to do is put the pi symbol at the end. And this is centimeters squared. For number 3, so what we're given is we're given the altitude, which is 40, and then we're given 41, which is the slant height, and that's the grand number that we need. Now, the problem is that we're missing the radius. So what we're going to have to do is we're going to have to find the radius by doing a squared plus 40 squared equals 41 squared. Or maybe you know your triples, and for a squared, you're taking the square root of 81, and you're going to get 9. So my radius is 9. So for the lateral area, all you have to do is plug in the numbers 41 and 9 into the lateral area formula on your formula sheet. So we have pi, and then my radius is 9, and then my slant height is 41. So you're going to type that into your calculator. So we have 9 times 41 to get 369, and then you just put the pi symbol. For my total surface area, you're using the formula, again on the formula sheet. So we have pi times 9 times 41. And then we have plus, it then says pi r squared. So I have pi, and then we have 9 squared. So in our calculator, you have 369 pi plus 81 pi, and you're going to combine 369 plus 81 to get 450 pi. Then you could put units squared for each of these. For number 4, this is a cylinder. And in this cylinder, they give us this height of 12, and then they also give us the diameter. So the problem with giving us the diameter of 10 is that we need the radius in order to use our formulas. So I'm going to cut the 10 in half to get my radius, which then is 5. So that is the number that we're going to be using. So I'm going to go straight to my formula on my formula sheet for cylinder. I'm looking at it. It says 2 pi RH. So we're going to set up 2 pi, and then we have our radius, which is 5, and then we have this height, which is 12. So in our calculators, you're typing in 2 times 5 times 12. We get 120 pi, and then centimeters squared. So you're just putting pi at the end. Pi has to be part of your final answer in order to get the question correct. And then for the total surface area, then we have 2 pi RH plus, now we have 2 pi, and then we have r squared. So again, my radius is 5. So in your calculator, you're typing in 2 times 5 squared, and you get 50 pi. So then from there, we can add 120 plus 50 to get 170 pi centimeters squared. For number 5, they give us the radius, and they give us the slant height, which is exactly what we need in order to find our final answer. So this shape is a cone, so I'm going to go look at my formula sheet, and it says pi RL. So we have for the lateral area pi, and then my radius times my slant height. So my radius is 6, my slant height is 13, and you don't have to find the actual height. So this would be the actual height. You don't have to find that. So we're going to type in our calculator 6 times 13 to get 78 pi. So we just put the pi symbol on the end, and then we have feet squared. So that is my lateral area. Next, we have our total surface area. So we take that 78 pi, and then I'm going to add the base, which is pi, and then we have r squared. So we have pi 6 squared. So we have 78 pi plus 36 pi. Type that in our calculator. 78 plus 36 gives us 114 pi, and then we have feet squared. For number 6, we have a hemisphere. So notice that there is a formula on your formula sheet for the lateral area and total surface area for a hemisphere. So in this problem, we're given our radius, which is 6, which is perfect, all right? If they gave us a diameter, the diameter would be 12. You'd have to cut it in half to get 6. So my formula says 2 pi r squared. So I'm just going to write in the number 6. So we have 2 times 6 squared in our calculator. And you're going to get 72 pi. And then for my total area, we have 3 pi r squared. So in our calculator, you're typing in everything except for the pi symbol. So we have 3 times 6 squared, which is 108. And then we have pi. Both of these are centimeters squared. All right, for number 7, what we're going to have to do, they give us this height inside, which is 8, and then they give us the diameter, which is 12. So what we're going to have to do is we're going to have to find the radius. So I'm going to take the 12 and cut it in half to get 6. And then if you notice, 6, 8, my triple, 10. So my 10 is the slant height. And my radius is what we're going to be using in order to find the lateral area and total area. So you're going to go straight to your formula sheet for a cone. It says pi radius times slant height. So we're going to write in the number 6 and 10. And we get 60 pi centimeters squared. And then for my total area, so we have 60 pi from above, and then plus pi r squared. So I'm going to write in the number 6. So we have 60 pi plus 36 pi. And we get 96 pi centimeters squared. And then finally, this last one, we have a sphere. Notice that we have this length on the outside, which means that this whole thing from top to bottom, it's 12. 12 ends up being the diameter. What we have to do is we have to cut the 12 in half and get both sides, which are 6. So the radius equals 6. Now, since it's a sphere, there is no lateral area. So we're just going to use our formula and use 4 pi r squared, which is 6. And you just have to multiply 4 times 6 squared in your calculator, and you're going to get 144 pi centimeters squared. So again, just to reiterate, all of the formulas that you're going to be using are directly on this formula sheet. So unlike the previous days where we were doing prisms and pyramids, where we had to find all the length times width and all the 1/2 base times height, you can just use your formula sheet, cylinder, cone, sphere, and hemisphere to complete the homework problems. Good luck!